morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. In this session, I would like to discuss about theories of failures, problem solving. So, how to apply different theories for problems. So, already in previous sessions, we have studied about theories of failures. So, there are 5 theories. One is maximum principal stress theory, maximum shear stress theory, and maximum principal strain theory, and maximum strain energy theory, and maximum distortion energy theory. So, how to apply these theories for design of a mission members? For what purpose we have to apply these theories? To avoid failure. So, it means for safe design. So, now we will see the problem. So, the given problem, how to apply these theories and how to calculate the stresses or dimensions of the component. So, whenever it is subjected to torsion loads or bending loads or direct tensile or compressive loads by using these theories. So, we will see. So, in this problem, the given load is axial pull type, that is 10 kilonewtons. So, it means the tensile load. The bolt consists of an axial pull of 10 kilonewtons together with a transverse shear force of 5 kilonewtons. The shear force is 5 kilonewtons. Find the diameter of bolt required according to, so first one, apply the maximum principal stress theory, and according to maximum shear stress theory, according to principal stress strain theory, and according to maximum strain energy theory and maximum distortion energy theory. Take here permissible tensile stress at elastic limit is 100 megapascal and the Poisson's ratio is 0.3. So these are the data available for solving this problem. Here two types of loads are acting. One is tensile load, another one is shear load. At this situation, find the diameter of the bolt. So what is the diameter of the bolt according to maximum principal stress theory or maximum principal stress theory. So different theory, apply different theories for find out the diameter of the bolt. So one by one we will see. So given load is here, given data first write down. The given load is a tensile load, that is 10 kilonewtons. Shear load is 5 kilonewtons. Elastic, that tensile stress, a permissible tensile stress is 100 megapascals. And Poisson's ratio you can represent with 1 by m, that is 0.3. Let the diameter of the bolt is the small d in mm. So find out the cross-sectional area of the bolt. So it is considered as a solid one. So the area of the bolt is A is equal to pi by 4 multiplied with d square. So d value we don't know. So we need to calculate the diameter of the bolt. So in terms of d, you will get area, cross-sectional area of the bolt. Now calculate the axial tensile stress. The axial tensile stress induced due to the axial load. The given axial load is 10 kilonewtons. Clear? So find out the axial tensile stress. Stress is equal to load upon area. It may be tensile load or it may be compressive load. But the axial tensile stress or axial compressive stress, the calculate according to given loads. So here the tensile load stress is, find out the given load is 10 kilonewtons and the area in terms of d. So you will get again the tensile stress is in terms of d 12.73 upon d square kilonewton per mm square. Similarly, calculate the transverse shear stress. Why? Because here shear load also acting. The shear stress is equal to shear load by cross-sectional area. Suppose the component is subjected to shear load, shear stress will be induced. The component is subjected to tensile load, tensile stress will be induced. The component subjected to the compressive stress, the compressive load, compressive stress will be induced. So apart from these three stresses, sometimes the component is subjected to torsion and bending loads also. In that time, you need to calculate the principal stresses. The principal stresses are normal stresses. So now, according to the maximum principal stress theory, the first will apply the maximum principal stress theory. So what is the empirical relation? According to maximum principal stress theory, sigma 1 plus sigma 2 by 2 plus sigma 1 plus sigma 2 upon 2 plus of multiply with sigma square root of sigma 1 square minus sigma 2 whole square plus 4 tau square. Clear? So here sigma 1 is axial tensile stress. Clear? And here sigma 2 is 0. So it is a uniaxial load. So only in pulling direction only one load is acting. Clear? In this case the sigma 2 is 0. So substitute 0 in place of sigma 2, only sigma 1 acting, that is tensile nature. So substitute the tensile stress value in this equation. And shear stress already calculated in terms of D. So substitute those values in this empirical relation, you will get the maximum principal stress theory. The maximum principal stress, the tensile stress is 15.36 by D square. So according to principal stress theory, the maximum tensile stress is equal to elastic limit value, that is the tensile stress is equal to what is the maximum stress at elastic limit. So here we calculated tensile stress value. So that is maximum principal stress is equal to the permissible tensile stress. In our problem given, the permissible tensile stress value 100. Clear? So equate this value to the permissible value. So you will get the diameter of the bolt according to maximum principal stress theory. So you will get 12.4 mm. Similarly, apply second theory. So that is the maximum shear stress theory. According to the maximum shear stress theory, first write down the equation. So what is the empirical relation? So tau max is equal to half of square root of sigma 1 minus sigma 2 whole square plus 4 tau square. So here also sigma 2 is 0. So substitute sigma 2 0 value in this equation. You will get, after simplification, you will get equation of square root of sigma 1 square plus 4 tau square. So substitute values sigma 1 and tau value in terms of D. You will get 9000 by D square Newton per mm square. According to maximum principal shear stress theory, shear maximum is equal to half of the permissible elastic limit stress value. So here the shear maximum is equal to 9000 by D square is equal to half of the permissible value. So we'll get D value 13.42 mm. In previously, according to maximum principal stress theory, the D value is 12.4. According to shear stress theory, 13.42. So next theory, according to maximum principal strain theory. So apply the maximum principal strain theory equation. Sigma T is equal to sigma 1 by 2 plus half of square root of sigma 1 square plus 4 tau square. So here also sigma 2 0. So here minimum principal stress is equal to sigma 1 by 2 minus half multiply with square root of sigma 1 square plus 4 2 square. So find out here in principal strain theory the maximum principal stress and minimum principal stress. The only difference is negative sign. Use negative sign for minimum principal stress and positive sign for maximum principal stress. So here you will get the minimum principal stress in terms of d square, and in terms of d, that is minus 2.2635 divided by d square, and maximum principal stress value in terms of d is equal to 15.36 by d square. So according to this theory, sigma t by E is minus sigma t by E multiplied with Poisson's ratio. So 1 by m. So 1 by m represents here Poisson's ratio. So equate this value to the given permissible value. So here you will get 12.7 mm. So apply the fourth theory. According to the fourth theory is maximum strain energy theory. So according to this maximum strain energy theory for safe design, apply this equation and you will get d value 12.78. Here also same procedure. So equate to this maximum strain energy equate to given permissible stress value. You will get 12.78. The last one is according to maximum distortion energy theory. So apply the distortion energy theory, sigma 1 square plus sigma 2 square minus 2 sigma 1 and sigma 2. So that is equal to permissible stress value whole square. So sigma T1 means here sigma 1 or sigma T1 is the maximum principal stress, and sigma T2 minimum principal stress. Clear? So apply and substitute those values, you will get d value is 13.4. So here observe here the d value according to maximum principal stress theory, maximum principal strain energy theory, and shear stress theory, and distortion energy theory also we have calculated. So which value is the larger? So find out. So in first case 12.4, and second case 13.42, and third case d value is 12.78, fourth one, and third case 12.7, and maximum distortion energy theory, the final value is 13.4 value. So this value is the larger value of the above. So here so take this diameter as a final diameter for your bolt. What he has asked, so calculate the diameter of the bolt whenever the bolt is subjected to torsion and high tensile loads according to theories of failures. So the bolt withstand the given bolt withstand according to the maximum distortion energy theory. Clear? So the diameter is 13.4. We can say the standard diameter you can take, that is 16 mm. So like that you have to calculate, you have to apply the theories of the failures for given problem. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.